Hello students, today we will be learning the topic work energy theorem and we will be discuss some spring problems in the upcoming videos. Okay, so what is work energy theorem? Okay, what is work energy theorem? The change in kinetic energy is equal to the work done by all forces. The change in kinetic energy delta K is equal to the work done by all forces W. So the change in kinetic energy means the final kinetic energy minus initial kinetic energy equal to work done. What is work done? Work done is integration F dot ds. We have already learned this in work power energy chapter. Okay, so the confusing part here is the sign. Okay, so you need not worry about the sign, just use proper vector laws to calculate F dot ds. Like look at this example. If this is a spring, okay, and the block, you're pulling this block, so the spring force will be in this direction and the displacement is in this direction. Okay, so the force here is in this direction and the displacement ds is in this direction, so this makes an angle of 180 degree. So work done here will be minus half kx square. Just use proper vector algebra rules to calculate the sign of f dot ds. Okay, in the upcoming problems, again we will discuss how work done can be calculated with proper sign. This was just an example. We can use another example as well, like a body is falling under gravity. Okay, g, this is the body of mass m, so mg is acting downwards, displacement is also downwards, so f mg downward, ds also downward, so direction will be positive, mgh. Okay, just like this. Just consider the direction of f and the direction of ds means the displacement, and check whether the angle between them is acute or obtuse. Okay, or 0 degree, 180 degree, whatever it is, calculate accordingly. What is f dot ds? It is basically f ds cos of theta, where theta is the included angle. Okay, now let us look at some important points in spring problems. Okay, suppose a block of mass m is approaching towards the spring with velocity u. So what will this block do? It will compress the spring. After a while it will be like this, compressed, right? The spring will be compressed. Okay, if the spring is compressed, then what we can say, like the velocity of the block is decreasing and the spring is also being compressed. So when the velocity of the block becomes zero, then the spring is at maximum compression. Okay, when the velocity of the block is zero, then the spring is at maximum compression. After that, what will happen? Again, the block will move in this direction, will start moving in this direction, slowly increasing its velocity, and the spring force will be in this direction. Okay, so the important point here is velocity at maximum compression is zero. We will use these facts in the upcoming problems. Thank you.